Wow, steam rising from the ground and boiling lakes? In New Zealand, the earth heat is clearly not far away. How do the Kiwis harvest this powerful energy source?
The second we get out of our camper van in Rotorua, we smell rotten eggs. It comes from a pool next to the parking lot. Steam mixed with sulfur rises from underneath the ground. In fact, we see steam all over town. The earth crust in this region of New Zealand is quite thin and porous, allowing the earth's heat to reach the surface.
The power and magnitude of the local forces of nature really become apparent in the nearby Waimangu volcanic valley. Lakes look like gigantic steam baths, geysers spout boiling hot water, and the banks of the streams are orange from algae that thrive in these conditions.
Close to Rotorua is Taupo. The town sits on the shore of New Zealand's largest lake, which is actually the caldera of a volcano. Outside of town, we find similar scenes to those in Rotorua.
In this part of New Zealand, it's so hot just beneath the surface that steam is rising up.
Clearly, the Kiwis are putting the Earth's heat to good use. But what exactly do they do?
To find out, we visit a nearby geothermal power station, Ngā Awa Pūrua. It is run by energy company Mercury in cooperation with the local Maori tribe, the Ngāti Tahu. Field manager Michael Stevens starts by explaining the basics of this geothermal field.
When we came to this field, we did a lot of research to try and understand the boundary of the field, and so our current understanding of the reservoir is it comes around here. This is the boundary, comes out and back around here. So that's sort of the Rotorua geothermal reservoir sits within that boundary. Okay, and then so what we have here through this section here, all these red lines are all our production wells, which we extract the geothermal fluid from, and we're they're up to 2.5 kilometres deep, and we're extracting geothermal fluid from 1,200 metres to 2,500 metres. That's where we're extracting the geothermal fluid out. And at the hottest temperature at the bottom of the hole is 330 degrees Celsius.
With the high temperatures from such depth, they can generate electricity efficiently.
So we're extracting fluid through all this area, and we're supplying 2 power stations with that fluid. A little power station here, which is 36 megawatts. We supply fuel for that, and then we supply fuel for this plant here, which is 139 megawatts. So we bring the fluid, put it through the power stations, we extract as much energy out of the geothermal fluid, and then once we've extracted the energy and we've turned that out into electricity, we then send all the fluid back down into this area here, and these blue lines are all our injection wells. We're sticking it back into the ground, and we're putting it back into the ground between 2,000 and 3,000 metres below the ground level. And we're doing that down into there, and then what happens is the fluid slowly heats up as it's going through the hot rocks, and it comes across here and flows around like this. There's a big fault running through here, so it hits the fault, it flows down here and then comes around like this and flows out that way. And that way we're extracting all the fluid out of the ground, taking the energy out of it, putting it back into the ground, it's heating up, and then it comes back around and helps support this area where we've extracted the heat. And that's how we make it sustainable over a long period of time.
Outside, we visit one of the wells.
So right here we have a production well which we're extracting about 800 tonnes an hour of geothermal fluid out of the ground to send to the power stations to generate electricity. It's approximately 2.5 kilometres deep, and actually if you pan over to here, the bottom of the well is to the green pasture. Halfway up the hill is the bottom of this well.
The geothermal fluid flows through pipes to the plant, where it is separated into liquid and steam to propel the turbine. Inside the plant, we see the massive turbine, which is turned by the steam to generate electricity. That electricity feeds the national grid.
So the amount of fluid we put through these 2 power stations, we generate roughly 170 megawatts per hour, and that's 24/7, 7 days a week, and essentially we are available 98% of the time in a year. So that's equivalent of supplying 170,000 homes of electricity. And because we're geothermal, we're called base load, so we provide that all the time compared to a hydro, which can be variant to how much rain you have, to how much water you can flow down your river, or wind, you're reliant on the wind, whereas we can just generate that 100% of the time. So that's how we're sort of base load and provide that security for the national grid in New Zealand.
As a result of the weather-independent, reliable production, the cost per kilowatt hour of electricity from geothermal energy is the lowest of all forms of electricity generation in New Zealand. All installations are monitored in the control room to ensure constant energy production. Back at the office, Michael explains why geothermal is not completely emission-free.
So geothermal is renewable, but it does have a certain amount of CO2 that comes out of the ground with that geothermal, and that's sort of come from the deep reservoir, and naturally comes out of the ground anyway. Over time, it will naturally come out through surface features over time. But because we're generating electricity and we bring it up a little bit faster. And it's a lot less than a fossil fuel power station, but there is still some. So what we're looking at, because we obviously want to be carbon neutral, so we're looking at ways of how can we put that back into the ground. So we're doing a few trials, and with the expectation to figure out how to stick that back into the ground. And also there's some other options out there. If we had a glass house parked beside the power station, you could use geothermal energy to heat the glass house. But then also if we could clean our CO2 up enough, then you can feed that into the glass house to feed the plants. And then again, we wouldn't be emitting any carbon because it would be going into the plants.
In addition, CO2 emissions are embedded in the materials and construction of the power plant. It means that although geothermal energy is renewable, it is not carbon-free. Geothermal energy supplies 17% of New Zealand's annual electricity requirement. Together with hydro, wind and other renewable sources, it means that more than 80% of New Zealand's electricity comes from renewable sources. Still, the most sustainable option is to save energy. After all, energy that is not needed does not have to be generated.
Dig some holes.
Why?
Apparently there's hot water on the beach. Well, let's find out.
Here we are, we've dug our, well actually our South African friends did all the work. They dug their own hot pool at the beach.
It's so hot. It's like, oh, if you go deeper, it just hurts. Yeah, it's unbelievable.
Nature can provide all the renewable energy we need. It is up to all of us to harvest it smartly and use it wisely.
Did you like this video?
And want to see more? Subscribe to our YouTube channel, like us on social media, become our patron on Patreon, or subscribe to our email newsletter on our website.